Hey everyone, and welcome. Today, we're diving into something you deal with every single day, probably without even thinking about it, the science of solutions. Let's get into it.
I mean, really think about it. You take a spoonful of sugar, you stir it into your hot tea, and poof, it's gone. But where did it actually go? Did it just vanish into thin air? Or is something else going on? That's the mystery we're unpacking today.
So, to get to the bottom of that mystery, we need to start with the big question. Just what is a solution anyway?
Okay, so at its core, a solution isn't just any old mixture. It's not like dumping sand in water, where you can still see all the little gritty bits. No, a solution is a special kind of mix, where one substance dissolves so completely and evenly into another that it seems to become one thing. If you want to remember it in the simplest way possible, just think of it like this. It's the ultimate smooth mix. No clumps, no separation, no floaty bits. It is perfectly, seamlessly blended. So what's the secret sauce? Well, solutions have a few key traits. First, they might look like just one thing, like crystal clear salt water, but they're really made of at least two different things. And the magic happens at the molecular level, creating what scientists call a homogeneous mixture. That's just a fancy way of saying every single drop of it is exactly the same as every other drop.
So how does this perfect blend even happen? Well, it turns out that every solution, no matter what it is made of two key players.
And here they are. Meet the solute and the solvent. The solute is the stuff that gets dissolved. Think of it as the passenger. It's usually the thing you have less of. The solvent is the substance that does all the work, the one doing the dissolving, the driver. It's usually the thing you have more of. So one gets dissolved, the other does the dissolving. Pretty straightforward, right?
Let's go back to our classic salt water example. That pinch of salt you add, that's your solute. And the water it disappears into, that's the solvent. Put them together, and boom, you've got a solution.
Okay, so we've met the key players. But how does that sugar actually pull off its disappearing act in your tea? Well, it's all part of a really fascinating process that I like to call a molecular dance.
Let's break this dance down. First, you drop the solute in. Immediately, the solvent particles are like, hey there, and they swarm and surround the solute particles. And then, this is the main event, they literally grab onto those solute particles and start pulling them apart, one by one, scattering them all throughout the liquid.
So you see, the sugar doesn't actually disappear at all. Its tiny particles are just pulled apart and distributed so perfectly and so evenly that they become too small for our eyes to even see. The sugar is still there. It's just been completely broken down and spread out.
Now, you might be thinking this whole thing is just about solids dissolving in liquids. But oh, solutions are way, way more diverse than just salt and water.
Seriously, solutions come in all kinds of combinations. You can have a gas dissolved in a liquid, that's the fizz in your soda. You can have a liquid dissolved in another liquid, like vinegar. And here's the one that might just blow your mind. You can have a gas dissolved in another gas. The very air we're all breathing right now is a solution, mostly nitrogen gas acting as the solvent for oxygen.
So we know what they are, we know how they form, but can we control how fast they form? Absolutely. Let's talk about some solution superpowers that you can use. Okay, the biggest factor, by far, is temperature. As this chart makes super clear, the hotter the solvent, the faster the solute dissolves. It's not even a close race. This is why sugar vanishes in hot tea, but just kind of sits at the bottom of iced tea. The hot water particles are just buzzing with energy, moving faster, and they can tear apart those sugar particles way more efficiently.
But heat isn't the only trick up your sleeve. You can also just stir it. Stirring basically forces the solvent particles to move around and find the solute particles more quickly. And finally, you can use smaller solute particles. Think about it. Powdered sugar dissolves way faster than a sugar cube because there's so much more surface area for the solvent to attack all at once. But there is a limit. You can't just keep dissolving stuff forever. Eventually, you'll reach a point where all the solvent particles are already busy holding on to solute particles. The mix is completely full. It literally cannot dissolve one more speck, and that is what's called a saturated solution.
Now, this might all seem like a pretty neat chemistry lesson, but you might be wondering, why does this really matter to me? The truth is, solutions are absolutely fundamental to our world and to our very existence. For starters, think about the air you're breathing in this very second. We just learned it's a solution of gases. It's pretty much the most essential solution for life on this planet. And what about our planet itself?
The world's oceans are one gigantic, incredibly complex solution of salts and minerals dissolved in water, and they drive our weather patterns and support millions of species. Think about life-saving medicine. So many of them only work because they can dissolve into our bloodstream, which is, you guessed it, a solution, so they can be transported all over our body to where they're needed most.
In fact, our own bodies are constantly using solutions to get vital nutrients from our food to every single one of our cells. You could say that life itself runs on solutions.
So let's recap the big takeaways, shall we? A solution is a super even mix where a solute gets dissolved in a solvent. And the key thing to remember is that those particles don't just vanish, they get pulled apart and spread out. And from the air we breathe to the blood in our veins, these smooth mixes are absolutely essential to everything.
And that brings us to one last thought I want to leave you with. Using everything we've just talked about, think about this. When you make a glass of chocolate milk from powder, which part is the solute and which is the solvent? I'll let you chew on that one. Thanks for watching.